Algebra 1's periods 1, 6, and 7. This is your absolute lucky day, Monday. You get 2 videos today. Can you believe that? Right, on that semester test practice test, there's a problem on there that says Jill is very frustrated with her Algebra 1 class. All right? So the problem reads something like this. So here's Jill. Jill is very upset with her Algebra 1, and so she decides to take that book that's causing her so much pain to the top of a 240 or a 224-foot cliff. And she is so happy because at the bottom there is a ravenous paper shredder. So Jill takes her Algebra 1 book and she throws it straight down into the jaws of the ravenous paper shredder at an incredible velocity of 96 feet per second. So the question is, Jill, on top of a 224-foot cliff, throws her Algebra 1 book down at 96 feet per second into the ravenous jaws of the paper shredder. How long does it take the book to get there? All right? So I can model this with the standard, the negative 16t squared minus, now this is the initial velocity. Now we threw the book down this time, all right? So it's going to be negative 96 feet per second or negative 96t. But my initial height was 224 feet above the ravenous paper shredder. I'm such an artist. All right, so set it equal to 0. Oh, standard form. Yes, we're in standard form. Set it equal to 0. Now, once again, I picked all the numbers so you can divide it by 16, and you get something very manageable. Negative t squared minus 6t plus 14, or you could multiply it by negative 1. It matters not. T squared plus 6t minus 14. Because it's that whole plus or minus thing right there that's going to fix that, and then the sign, of course, is going to flip the other one. All right, so you use the quadratic formula. You identify your A, your B, and your C. Remember, A is the coefficient in front of the squared term. In this case, it's a negative 1. B is the coefficient in front of the linear term. In this case, it's a negative 6. And 14 is the number hanging on the end. That's C. Plug them in. So T is now equal to negative B, positive 6, plus or minus b squared, negative 6 squared, minus 4ac. Now, I already changed the positive or the negative to a positive because negative times negative is positive. And if you clean all that up, you get t is equal to 6 plus or minus the square root of 92 all over negative 2. Okay? And then you'll, 92, there is a square factor in 92. So take the 4 out. 4 times 23. Square root of 4 is 2. So now this is where it gets interesting. You have 6 plus or minus 2 square roots of 23. Okay? But when you divide it by negative 2, like you're supposed to, you get negative 3 plus the square root of 23 or negative 3 minus the square root of 3. Now that's t. Remember, that's time. Now you know that negative 3 minus the square root of 23, that ain't going to work, is it? So negative 3 plus the square root of 23 is how long it will take Jill's book to meet the jaws of the ravenous paper shredder. So she's up at their top going, ha, 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 ha. In negative 3 plus the square root of 23 seconds, you'll be shredded. Well, how long is that? Well, it's about 1.79583 seconds. Okay? Chomp, 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 chomp. All right. Now, the next one you have Super Dave Osborne throwing a piano again. But this time, Super Dave Osborne is 256 feet below where the piano is going to land at an elevation of 0 feet, okay, above sea level, okay? So he's in a 256-foot hole, and he basically wants to throw it to the top of the hole, okay? Now, Super Dave is going to throw this piano at an initial velocity of 320 feet per second, all right? And he's going to throw it up. It's going to reach some maximum height, which is the vertex, and then it's going to come down here, and it's going to land at 0, okay? So now we can model this once again, negative 16t squared plus 320t. That's our initial velocity, minus 256, because that's our initial height. We're 256 feet below where we want to be, okay? So here's the question. How high did the piano go and how long did it take to get there? Well, that's the vertex, okay? So when you see this question, how high did the piano go and how long did it take to get there, think vertex, okay? Vertex, t is equal to negative b over 2a. Negative b, in this case, b is 320. Do you see where I found b, 320? And what's a? Negative 16. Do you see where I got those? Negative 16 is the coefficient of the squared term, that's a. B is the coefficient for the linear term, that's 320. Blah, blah, blah. All right, so now t is equal to 10. So it took 10 seconds for this piano to go and get there. Now, that's the how long part. How high did it get? Take the 10 and plug it in, okay? Everywhere you see a t, put a 10. So the height after, at t, the height at 10 seconds, plug it all in, and you'll get 1,344 feet, okay? That's how high the piano went, okay? And that's above sea level, by the way, okay? All right, now, here's the next question. How long did it take the piano to reach elevation 0? Well, you set the equation equal to 0. Okay, now I'm going to divide it by 16 again, and I'm going to plug all that mess in there, and that's how it cleans up. T is equal to negative 20 plus or minus 4 square roots of 21, all divided by negative 2. 400 minus 64, that's 336. Now, how did I get that? Take 336 and divide it by 4. And then divide it by 4 again. Well, 4 times 4 is 16. So 336 is equal to 16 times 21. What's the square root of 16? 4. Okay? And then when you divide that by negative 2, now this is where magic happens. Negative 20 divided by negative 2 is 10. 2 goes into 4 twice. Now, which one of those do you suppose you want? You want negative 20 minus 4 21s, or do you want negative 20 plus 4 square roots of 21, okay? Or 2 square roots of 21. Okay, there it is. We're going to take the positive value, okay? That's how many seconds it takes the piano to hit 0, all right? Okay, so there's a couple more semester test practice problems for you. And again, I'm being very kind, okay? But it's the mechanics of the problem that I need to make sure you know how to do, okay? All right, I got a couple more of those. Next thing you know, somebody wants to decorate their desk with bunting or something like that. I'm going to figure out a problem to wrap stuff around a desk, and you get to tell me how much it's going to cost based on some weird dimensions of the desk. Okay? All right. So we're taking a little time. We're doing a little review. I want to catch this stuff while it's fresh in your head before we move into the next chapter. We are going to spend a little time graphing square root functions and some other really cool things like that. But I just don't want to lose this, so here's a little review for you. All right, May's out.